Section A3, geometric sequences in series. Objectives. Again, you can pause to read. I am moving on to the next slide. Vocabulary key concepts: geometric series, common ratio, sum of a finite geometric series, sum of a infinite geometric series. Next slide. It says use a graphing utility to create a table showing the sequence of partial sums for the first 10 terms of the series. This is related to problem number 11 and 12, part 1 of video 1 or section 8.1. So here we go. We're going to find the sum of the first term, which is basically just coming up with the first term. And this is what this means. Notice that the lower limit and the upper limit match. So it's just basically the first term. Turns out to be this, 4. Plug in n equals 1 here, and you can see that it's equal to 4. How do we get the next term? You're going to take the sum of the first term and the second term in this series, geometric series. So once you do that, basically you're computing this, and you end up with 4.8. Again, you're adding the first term and the second term. Notice that the lower limit is 1, the upper limit is 2. And then from here, this is the first 3 terms of this. The sum of the first three terms in this series is 4.96. Notice that the lower limit is 1, the upper limit is 3. So it's talking about only 3 terms that you're adding. And then you can come up with the rest. And how we're going to do this, we're going to use the graphing utility. And these are the steps that you follow so that graphing calculator can do this for you. Start with second, stat, ops. You go down to 6. You want the cumulative sum. Then you go to second, and then stat. Now you want the sequence that is generating by this expression here. And then you punch in whatever this expression is, which you see here, 4 times 0.2 raised to the x minus 1 power. And again, we use x because that's what is built in, comma x 1 to 10, 1 through 10. Once you do that, you press enter. And then this is what you're going to have on the screen. The first number that you're going to see is 4, which matches this, 4.8, and so forth. And again, I can clarify any questions that you might have on number 1 in class. Next slide. It says find the sum, and then it says use a graphing utility to verify your result. So I'm just basically going to find the sum without the graphing utility, and then you can verify yourself. So here you have to use this formula, the sum of a finite geometric series. And again, this is something that you saw in Algebra 2. Let me highlight what this is. This is the first term of the series. This is the common ratio. And again, this is the common ratio, and this is the number of terms that you're adding. So here we go. So since the lower limit is 1 and the upper limit is 9, you know that you're adding 9 terms. First term in this series is 1. Plug in n equals 1 here, you get negative 2 to the 0 power, which turns out to be 1. The common ratio is whatever is being raised to a power, and you learned this in Algebra 2. You substitute the information into the formula you see here. You simplify, and you get 171. Number 3. Here it is. Let me highlight this. Notice that the lower limit is 1. It's now 1 is 0. And the upper limit is 15, which means that your n is going to have to be 16. So you're adding a total of 16 terms in this series, in this geometric series. So you come up with the number of the number of values is 16 that you're adding. The first term is 2, and the common ratio is 4/3. At this point, you substitute it into the formula. You get the following, punch it into the calc, and you get 592.647. Next slide. It says find the sum of an infinite geometric series. Notice that this is not finite. This keeps going forever. The lower limit is 0. The upper limit is infinity. So here we go. How do we do this? We're going to have to use the formula you saw in Algebra 2, which is this. And I showed you this formula in video 8.1. So here we go. So we need to find out what the common ratio is. The common ratio is negative 2/3. And notice the negative 2/3 is less than 1. So we get a sum. This actually converges. Since it converges, we find the first term, which is 9, and the common ratio is negative 2/3. You plug it into the formula, which is here. You simplify this and you get 27/5. So the sum of this series from 0 all the way to infinity is actually 27/5. Let's go to number 5. This is the geometric series that we're looking at. We look at the common ratio. And notice the common ratio is not, when you take the absolute value of it, is not less than 1. So that's why we have no sum. And this happens sometimes. And you learn this also in Algebra 2. Now here they don't give you actually the summation notation. They just give you the following expression, the following series. But what we can do is we can actually find the common ratio by taking a sub 2 divided by a sub 1 and a sub 3 divided by a sub 2, and notice that these have to match, otherwise it's not a geometric series. It turns out that this is a geometric series. We have a common ratio. The common ratio turns out to be negative 5/6. This is your A2, this is your A1. And then we need the first term in the series, which turns out to be this one. That's what we have here. We plug it into this formula. Oh, excuse me. First we need to determine if we actually get a sum, and this is true. When you take the absolute value of negative 5/6 is less than 1. So then we plug it into the formula. We simplify this, and we end up with negative 36/11. Let's move on to the next slide. Here's the last problem. Here's number 7. It says the sides of a square are 27 inches in length. So let me just highlight that. So this is 27 inches, and so is this one. And then new squares are formed by dividing the original square into 9 squares. So now here we have 9 squares out of this. So if this is 27 and you divide and you have 9 squares, now you know that this is the distance from here to here is 9, and the distance from here to here is 9. Now what's the area of this square? 81. And I forgot to continue to read the problem. But then it says the center of the square is then shaded. So here's the figure. If this process is repeated 3 more times, determine the total area of the shaded region. So now let's repeat the process again. So I'm going to divide this into 9 squares, and then I'm going to shade the middle square. So what is the dimension of this square? It turns out to be 3, and you should be able to follow, which means that the area of this square is 9. If this is 9, and you have a total of 8 little squares, the total area of these little 8 squares is 72, which is 8 times 9. Now I can find out the area of all these little squares that you see here, all the way to the last one, but I'm not going to. I'll leave this as a question mark. And this is asking me to find the area of this figure, the total area in this figure. Okay, how am I going to find this? Well, I'm going to use the fact that this actually represents a geometric series, and I'm going to use the fact that I can find the common ratio. Since I know A2 and A1, I can do 72/81, and this is the common ratio. So now, to find the area of figure 4, this is what I'm going to do. I am actually going to generate a rule that gives me these terms, these 2 terms in the geometric series. And I want the sum of the 4 terms, the first all the way to the last, which is, to the 4th one. And notice that this rule actually generates for the when n is equal to 1, it gives me 81. When n is equal to 2, it gives me 72. And if you want to find out what the area these little squares are, you can plug in n equals 3 here and it'll tell you, which I'm not going to. Who cares? So all I'm going to do now is actually find the sum. And notice that this is a partial sum of a geometric, which means that I'm using this formula that you saw earlier in the video. This is your first term, this is your common ratio, this is the number of terms you're adding, 1 minus r. You simplify this, you get the following, and then you punch this into the calc and leave it as a fraction, and you end up with this. If you have questions on number 7, just talk to me in class and I'll be more than happy to clarify it. But this concludes the video.